Hello everybody, here we are starting Geometry Chapter 10, but we're going to go back in time a little bit, back to our first chapter into some vocabulary terms. So Chapter 10 is about volume, and so in order to talk about volume, we need to know the difference between the solids, which are the 3D shapes. So our objectives are to be able to visualize and identify and draw 3D geometric solids is what it's called, and then also be able to figure out what those solids would look like if I had to flatten it out, because some of our volume problems will require us to find certain areas of things. So kind of like a surface area problem. And then maybe draw some pictures based on a real world problem. So let's just start with doing the vocabulary. So space itself is the set of all points. Oh, points, there we go. It's not contained on a plane, so not in a flat surface like a plane, because space is all around us, so it's three-dimensional. All right, now cone, I mean, we can describe it and we can draw it, so we might want to do both. Depending on your art skill level, this might look really terrible, and that's okay. But just give it your best shot. So a cone has a circular base, and then it goes to a point. And notice I drew my cone like an ice cream cone, but you might also draw it, I don't know, an elf hat. Or some people get really fancy and they're able to draw it to actually look three-dimensional here with the fancy lines behind it there. But to be a cone, you need one circular base, and then the lateral sides come up to a point. And I put rises to a point, but I guess if it's upside down, it would be falling to a point. But that is a cone. All right, a cylinder. A cylinder would be like a soup can, or maybe a can of vegetables. Pop cans are similar to it, but they're not exactly perfect cylinders because of the weird shape that they have on the top. But a cylinder is kind of like a cone because it has a circular base, but it actually has two bases. So the top and the bottom are considered the bases. So two circle bases. And then the lateral side, if you were to unroll it, it actually makes a rectangle, excuse me, or it could be a parallelogram if the cylinder is slightly tipped. So lateral side connects the bases. All right, next term, pyramid. Now, there's lots of different types of pyramids. So to be a pyramid, you need to have some sort of base shape, and then all of the corners or the vertices of that base shape are going to go up to a point. If we think about maybe like the Egyptian pyramids, those have a more square base. And so maybe a four-sided bottom here, but the base can be really any polygon. So it's going to have one base that is a polygon. And then all of the lateral sides are triangles that meet to a point. And again, it's totally dependent on whatever base shape you have. So you could have, like this one, it's a square base, or you could have an octagonal base, or as many sides really as you want. On that base, it just has to be a polygon. All right, for the prism, it's kind of like the pyramid where the base is dependent on whatever polygon you're choosing, but it's going to go up like a cylinder to that same base shape. So if I were to draw something like a cereal box, where I'd have the top and the bottom the same, that would be a prism. So this is an example of a rectangular prism because the base shapes are rectangles. So this time we have two bases. They are congruent polygons to each other. And then the lateral sides connect those two bases. And again, usually the lateral sides are rectangles or possibly parallelograms. Okay, hemisphere and sphere. So if you think about the globe is a sphere, and we live in the northern hemisphere, which would be the top half of the globe. So I'm going to start with the sphere, and this right here is a circle that is different than a sphere. So I need to make it look three-dimensional, and so I can make it kind of look like those basketball lines coming around so that you can see that it's got some dimension, and we would have a center point in that sphere. So a sphere is this center point plus all of the points that are the same distance away from that center point, which is kind of the same definition as a circle. We start with a point and we measure out a certain distance, and all of these points all around make up the circle. But that's on a flat plane. So when we're talking about a sphere, it's in a space, a 3D situation here. So it's the center point, and all points equidistant to the center. Okay, now for a hemisphere, we're just going to take the top part of that sphere or just the bottom part. So I'm going to draw it two different ways. Taking the top portion, rounded with a circular base, or I could make it look like a bowl. So a hemisphere is half of a sphere plus the bottom or the base that is circle, plus the circle base. So once you slice a sphere in half, it creates a new surface. So that's that circle base. All right, and finally, a net is when you can take a 3D figure that you can totally flatten out into a 2D figure. So a 3D figure you can cut out and fold to create, oh, sorry, I got that backwards. A 2D figure is the net, and you can cut it out and fold it up to create a 3D figure. So this is just one example here. Let's say I had that cereal box. If I were to, unfold the cereal box, I would have the front, the nutritional label, the ingredients, the back, the top flap, and the bottom flap. And I realize on a cereal box there's two flaps on the top, but just thinking about just the box itself. So this here would be the net. This is the 2D of the 3D version. Wonderful. Okay, now as we get into these solids, there's a lot of information here. We're going to condense it down a little bit, so we're not going to cover everything, but we just need to be able to pick out the different parts of the solids. And so the important terms here are the items or the things that make up the solid. So when we have a corner like this, that's a vertex. When we have a flat part like this, that's called a face. Anything flat is a face. And then where two faces come together, trace this face. You can see both of these faces came together right along here. That's called an edge. Okay, now, yes, this is considered a pyramid, but it's also considered a polyhedron. And a polyhedron is like the same thing that you could say, oh, a square is a polygon. A pyramid is a polyhedron. And that's because it's a 3D solid. So this is a polyhedron classified by the number of faces. And so if we think about, how we did polygons, 3 sides is a triangle, 4 sides was quadrilateral, 5 sides was pentagon. We have prefixes for polyhedrons as well. We have to have at least 4 sides to make a solid. And then that is not the same prefix as a quadrilateral. The prefix is tetra. So up here, nope, that one has 5 sides. So if you had a 4-faced 3D solid, it would be a tetrahedron. 5 is pentahedron. 6 is hexahedron. 7 is heptahedron. 8 is octahedron. 9 is nonahedron. And 10 is decahedron. So polyhedrons are named by how many flat surfaces they have. Polygons, the 2D shapes, are named by how many sides they have. But the prefixes are almost the same. Okay, so let me just zoom out here because we are not going to cover this entire thing. So here's some examples that you could go through and try naming. And so there's polygons and polyhedrons in here. So for example, this one has 5 sides and it's a flat figure. So this would be a pentagon. Whereas this figure to the left has 5 faces. It's a 3D. So this would be a pentahedron. So if you want to try some of those examples, go right ahead. And let's see here. This is, oh, okay. So this particular polyhedron is made up of pentagons that are all the same size and shape, but it's got 12 of them all together. So this would be a dodecahedron. But because it's got all of these pieces the same exact shape and size, it's a regular dodecahedron. So this is a regular dodecahedron. So the dodeca means 12, and the hedron part means it's that 3D solid. All right, again, we're not covering all of this. Here's some examples of prisms. Zoom in a little bit here. Oops. That is clearly too close. Page back. Let's try that. Okay, so here's some prisms down here. And like I said before, a prism is all dependent on the base shape. So if you look at this prism, it's got a rectangular base, where this one has a triangular base, and this one has a hexagonal base. So they're all prisms because the top and bottom bases are the same shape, and then they're connected. But the type of prism is based on what shape is on the top and bottom. And a prism can be straight up and down, or it can be slanty. That's called an oblique prism. And again, if you want to try classifying some of these prisms, feel free. For example, this one here has a trapezoidal base. And even though that's on the front of the shape, I know that's the base because behind it is the exact same size shape here. So I'm not looking necessarily always at the bottom, I'm looking for the 2 shapes that are the exact same. So this would be a trapezoidal prism. And again, if it's slanted, it's called oblique. I guess kind of how your obliques are on the sides of your ab muscles, and that helps you slant, I guess. Okay, pyramids are named the same way based on their base shape. Whoops. And so if I look at some of these pyramids here, this one has a rectangle looking base, but it could also be maybe a parallelogram. And so it's a little bit deceiving between rectangle and parallelogram because of how we're looking at this 3D shape from a 2D vantage point on the paper. So as long as you're, close, that's fine. Rectangles are parallelograms. So this would be a rectangular pyramid. Whereas if I look down maybe on this example here, 1, 2, 3, 4, 5, 5 sides on the bottom, this would be a pentagonal pyramid. All right, more solids. So cylinders are solids, but they are not polyhedrons because they don't get created by polygons. They get created by circular or circles, I guess I should say. So these are examples of cylinders. And remember, a cylinder has a top and bottom circle that are congruent, and then they are connected, and sometimes they're connected straight up and down, and sometimes they're slanted. And so that would be oblique again if it was slanted. A right cylinder is just like the typical can of beans or whatever you're looking at. It's just straight up and down. The connection between the centers of those circles is called the axis, but the height itself is called the altitude. So on a right cylinder, the axis and the altitude are the same thing, but on an oblique cylinder, they are not. All right, another solid that is not a polyhedron would be a cone. And again, you have a circle base for the cone, and then they all those points go up to one point. And if it's slanted again, that would be an oblique cone. And then same thing here, our altitude is our height. So from the vertex straight down perpendicular to the base, not the connection here because that would be much longer. So the altitude is the height, the straight up and down. All right, spheres, another type of solid with a curved surface. So a sphere, remember, is like the basketball, where a hemisphere is only half of that, but it includes that new surface that's created when that sphere gets cut in half, which is called the great circle. Awesome. Well, thanks a lot, everybody. Have a great day.